This is your favorite channel, BayesianQuest.com, where we unravel the enigma of data science. Today we start a new series where we will learn how to build a machine translation application. Let's dive in. Let's get an overall context of what we are trying to achieve in this series. Now in this series we will invest our time in understanding an end-to-end perspective of a use case. Now what is this end-to-end perspective of a use case? So end-to-end perspective means this series would cover right from setting a business context and then finally building an application and deploying that applications. So that's an end-to-end perspective of a use case. Let's cover or let's see what are the kind of topics which we're going to cover in this whole series. So you'll have to start from the bottom of the slide. So first we will start off with understanding the overall landscape of solutions which is available for machine translation. And then we'll be using sequence to sequence model architecture in this applications, and we will explore what a sequence to sequence model architecture is for machine translation, and also understand what are the various architecture choices, especially in the sequence to sequence model architecture, which are fit for machine translation applications. And then what we'll do is in the next two series or next two blocks we will try to understand the LSTM model in specific from a mathematical perspective. So what we'll do is we'll derive the forward propagations, and in the next step we will try to understand the backward propagation mathematical derivations. Now these two videos are going to be a little mathematical oriented, and you can obviously skip this, but I would recommend that you just understand what just to get a feel of what happens in a forward propagations and what happens in a backward propagations, especially in an LSTM context. Now after that, after we understand the mathematical base of this, then what we'll do is we'll go ahead and build a prototype of the machine translation model using either Google Colab or a Jupyter Notebook. You can use either of them. So that's the prototype which we'll build. Now from the prototypes we build in these Jupyter Notebooks, and from the prototype now we'll have to progress into how to build in production. And in production we will build using scripts. Now what we'll do is, from the prototype, how do you build it into production grade script? That's what we will try to address in the penultimate video. In the last video, what we'll do is once we build the application in production in using scripts, then we build an application using Flask and then deploy that application in a hosting service called Heroku. So this is what we will cover in the complete series. So when we start learning about machine translation, it's always a good idea to start from how it touches our day-to-day life. This machine translation was always a tough nut to crack because languages are inherently complex, because there are so many variations in the structure and lexicons when we traverse from one language to another. And because of these facts, translating from one language to another was always difficult. So however, over the past decade, we've seen some trailblazing advances which have happened in the whole machine translation application, just because of the fact that it was tough, and therefore it attracted some of the greatest minds to apply to this problem. And because of many of these advances, right from if we look at the whole evolution, in a few minutes from now, right from the early stages into to neural machine translations and now transformers, so much has evolved, and therefore machine translation has become very ubiquitous in our life. So we don't see the effect of many of these machine translation applications, or you don't feel the effect, but it is always there. It is hidden in many of these applications which we use in our daily lives. Some of the now machine translation applications are there in your watches, in your browsers, in your tablets, and many of those devices which we use in our day-to-day lives. Obviously the most prevalent example is this Google Translate applications, which not only detects the language in which we're typing, but it also translates into multiple different languages which are required. Now all these things are didn't come overnight. Now these were possible because of a lot of evolution which has happened in the whole machine translation in solutions. And next we'll see what is the kind of evolutions which has been happening in the overall machine translation landscape. So as I said earlier, the advances which is happening in the machine translation applications right now didn't happen overnight. There have been a set pattern of evolutions, and this evolution of machine translation application can be divided into three distinct phases. Now, the first phase is called the classical machine translations, and then came what's called the statistical machine translations, and now it's predominantly what is called a neural machine translations. Now we'll dive into each of these to understand what are those nuances of characteristics in each of these distinct evolutionary phases. So the first phase of machine translation evolution was called the classical machine translation. Now this classical machine translation depended heavily on this linguistic rules and deep domain knowledge to do the translation. Now there were predominantly three different approaches for classical machine translation. Now the first one was called the direct translation, which was like direct word-to-word translation between the source language and the target language. Now let's take an example. Here the source language, which is English, which states Mary didn't slap the green witch, which translates into a Spanish equivalent as Maria no viona bofeta la bruja verde. Please excuse my pronunciation. Now, if you just map from the target language, which is a Spanish, into a word-to-word translation into a English sentence, it would read as Mary not gave a slap to the witch green. So if you can see that a word-to-word translation, if you just map it to your English language, it doesn't form a very coherent sentence. So this direct translations also required, along with this word-to-word translation, a lot of reordering of the words into the target language, and these reordering was based on complex linguistic rules which were created between the source language and the target language. Now the second approach, called the transfer method, takes a completely different approach. Now we have seen earlier in the direct translation approach that there is a structural difference between how the source language, which is the English language, and the Spanish language, the target language, which is the Spanish language, has. Now in terms of how these words are mapped and how the ordering of those words after translation happens. Now these are all based on the structural differences between these languages. Now transfer method, what it does is it looks at or taps at these structural differences between the language, and it just codifies these structural differences, and this is called a contrastive knowledge. So these structural differences which has been codified is called a contrastive knowledge, and these contrastive knowledge is again a big set of linguistic rules which has been made, and this was used for translation from one language to the other in the transfer method. Now the last method, which is called the interlingua method, is like how a human translator works. Now when a human translator works, they do not translate word by word. What they do is they understand the meaning from the source language and then translate based on the same idea into a target language, and that's how a human linguist works and does machine translation. So this interlingua method, it adopts a kind of similar approach. It doesn't translate word by word, but it just translates the idea or the essence of the source language into a target language. So these were the three different approaches which was adopted in classical machine translation. Now, classical machine translations worked well for many different use cases. However, as you would have seen, classical machine translation depends a lot on these complex rules, linguistic rules which were required, and the deep domain knowledge which was required. So for a certain period of time it worked, but when you had to build such systems where you have to translate between one source language to multiple different languages, or you have to build systems between different source languages and different multiple languages, like what we have done in Google Translate. Such systems required huge amount of linguistic rules and large amount of deep domain knowledge, which was becoming difficult, and the complexity also increases manyfold with such system. So there was a need for an approach which was different from this domain intensive classical techniques, and this led to the rise in popularity of the statistical methods in machine translation, which we will see next. So when we explored the classical methods, we understood that the over-dependence of domain knowledge in creating this linguistic rules and dictionaries. However, it was also a fact that, no amount of domain knowledge was enough to handle all the intricate nuances of the language. So what if phrases, idioms, and specialized usage in language do not have any parallels in other languages? In such circumstances, what a linguist would do is to go for the closest match given the source language. Now, this idea of selecting the most probable sentence in the target language, given a sentence in the source language, is what is leveraged in statistical machine translation. Now, statistical machine translation methods builds a kind of a probabilistic models that aims at maximizing the probability of the target sentence, which best captures the essence of the source sentence. So, in probability terms, we can represent this as argmax of T, which is your target sentence given your source sentence. Now, T and S are the target and source languages respectively. Now, the above form is a representation of a kind of a posterior probability as per Bayes' theorem, and this is proportional to the argmax of S, which is your source language given your target language, into the probability of the target language. Now, the first term, which is a probability of your source language given your target language, is called a translation model, and this can be interpreted as what is the likelihood of finding the source sentence given the target sentence. And the second term, which is the probability of the target sentence, is called a language model, which represents the condition probability of a word in the language given some preceding words. Now, what the statistical model aims is in finding the conditional probabilities of words within a corpora, and using these probabilities find the best possible translation. So now you have a large corpora of words and sentences, and find the conditional probabilities of the word within these corpora. Now, statistical machine translation models make use of these large corpora or text available on the source and the target languages. However, even though statistical methods were effective, they also had some weaknesses. Now, this method was predominantly focused on phrases being translated, thereby compromising on the broader context of the target language. Now, what happens was the context in which these sentences, both the source language and the target language existed, was being lost. So this method also struggled when required to translate to a target sentence, which was completely different in context from the source context. And these shortcomings paved the way to advances in other methods which were more robust in retaining the context between the source and the target languages. And this led to the rise of the next phase, which we're going to see, which is the neural machine translation phase.